Hi everyone, welcome to the second session of today's meetup. We will be talking about multi-account and multi-region testing in LocalStack and how it enables us to manage and deploy resources across multiple accounts and different locations. And also, this practice helps us enhance the robustness, scalability, and compliance of our applications. So, as promised, a little bit about me. My name is Sannya Singhal. I'm a software engineer here at LocalStack. I have been with the company for about an year and a half and focusing on cross account and cross region functionality in our core product. I also serve as the service owner for KMS, Transcribe, and I'm working on an upcoming service, so stay tuned for it. It is DMS, the Database Migration Service, and its use cases, but it is in the preview state. You can reach out to me on my company email or community Slack channel for any queries and feedback, and that's my GitHub handle. So if you're new to today's topic, I'll start with a quick introduction on what is multi-accounts and what is multi-region, and then I'll talk about some of its benefits, and then deep delve into demo to showcase how LocalStack supports these features. So to start with, what is multi-accounts? Basically, it is the practice of using multiple AWS accounts to manage and organize your resources, your applications, and environments for better isolation, better security, and better scalability. Isolation, if we talk about, it is basically if we have, say, different kinds of environments and it can be isolated from each other. For example, say you have different environments for dev, testing, and prod. So it basically reduces risk of accidental changes that would affect any kind of breaches in your environments. In security, what you can do is using multiple accounts, each account can have its own security controls, its own policies, and its own IAM users, roles. IAM is basically the identity and access management, which we will be discussing very shortly. Then we have scalability. It basically, in multiple accounts, it basically helps in scaling resources very efficiently because you can just tailor each account to specific workloads and your application. In the diagram here, you can see we have two different accounts. One is account A and the other is account B. Basically here, the step function in account A is trying to invoke a Lambda function which resides in a different account. So this is a multi-account. Moving on to multi-regions. What is multi-region is basically the practice of deploying and managing your resources across multiple geographical locations, right? So these regions are basically set by AWS, where it has different AWS data centers. For example, in US East 1, which resides in North Virginia, then you have EU West 1, which is in Ireland, and then AP South East 1, which is in Singapore. So all across different locations, right? And each of these regions is basically a separate geographical area that is isolated from others to provide greater fault tolerance and stability. And thus, it gives us benefits like higher availability, disaster recovery, and a lower latency. Now, looking at the diagram on the right side here, we see that we have three different regions. One is US West 2, EU West 1, and AP South East 1. And we have different resources in our different regions. Now, when a Docker client pushes an image to this ECR repository here, the put image event here will be issued. And now we can set up a CloudWatch event rule to receive this event, which will invoke a target code build. Now, this code build tries to, say, pull the image from the ECR repositories and finally pushes this image to different ECR repository residing in different AWS regions, right? So a source in US West 1 is trying to request on services which are residing in EU West 1 and AP Southeast 1. Now let's delve into some fundamental concepts and terminologies that will be an integral to our demonstration further. And just a disclaimer, the definitions provided here are within the limited scope of today's discussions. So starting with IAM, it is the Identity and Access Management Service that helps us securely control access for our AWS resources. Now, these resources could be SQS, S3, Lambda, etc. That is, these are basically the permissions for your AWS resources. Next is principals. Now, these permissions are attached to principals. These principals can be a user, a role, or a service that will use these permissions to send the request, right? Now, then we have actions. Actions are basically the operations that we want our principals to perform. That is, the principals will use these actions and these principals will basically use these actions on the resource. Talking about policies. Policies in IAM are JSON permissions that control what actions a principal can perform and on which resources and which conditions. These principals could be a user, a role, a group, service, anything, right? A basic example of action could be, say, if you want to send a message to an SQS queue, that would be an action, right? Furthermore, there are various types of policies, but we will focus on discussing just two of them today. First is the identity-based policy, where each policy is attached to an IAM identity. An IAM identity could be a user or a group to which these users belong to, and grants permissions to an identity. Whereas, on the other hand, we have the resource-based policies, which are attached to the resources. Several services support resource-based policies in AWS, for example, S3, SQS, KMS. Now we have an example policy here, and we have different fields set in these policies, right? First is the version. Version is basically the current version of the policy language, and it is set to this date, 2012, 1017. Then we have the statement element, which could be a single statement or an array of statements. Then you have the SID, which is an optional identifier, and you can just use it to describe what your policy statement stands for. Then you have effect. What is effect? The effect basically states that whether or not to allow or deny an explicit action, right? So it basically states like whether this will allow or deny this action for a principal on this particular resource. An action, as we discussed, is an API operation that the principal will use on the resource. Here I have used S3 list all my buckets. Then you have the resource. It could be any AWS resource. Here I have used a wildcard asterisk, which means all the resources. Now, we need to have some key points that we need to consider while working with IAM enforcement in LocalStack, right? So IAM is supported by LocalStack, but it is disabled by default. And you can enable it by using the enforce IAM flag and set it to 1. LocalStack also has a very interesting feature, which is the explainable IAM feature. And it basically provides a lot of helpful information in the logs if and only if the enforce IAM variable is set to 1. We also have IAM soft mode and IAM policy streams. Like in IAM soft mode, you can basically review your logs and assess whether your requests would have been denied or allowed while executing your stack without causing any disruptions. And IAM policy stream could basically use this mode and generate a stream of IAM policies as your requests would come in. So this feature basically aids in identifying the correct permissions for your applications, but that's out of scope of today's discussion. So we can have a look at it in the further sessions. Let's hop on to an example to gain insights on how things operate in practice on LocalStack. So what I'll do is just spin up a LocalStack container. And here I have used the debug mode and set it to 1 and set the enforce IAM variable to 1, right? Now I'll open my IDE and I have 2 panes here. The first pane, I'll use it for first account A, and we'll assume the second pane to be for account B, right? Firstly, I'll set the AWS access key ID, that is the account ID, to 12 zeros, right? And my AWS secret key access to test. What I'll do next is check whether this is using the correct account ID or not. So yeah, I get the same account ID as I have set here. Now I'll try to make a bucket here by the name test bucket. And my bucket is correctly made. I will try to access this, I'll try to list this test bucket from the second account, right? So let's just put some object. I am putting an empty folder in my test bucket. Here I have just created an empty folder here and I'll just create this. Okay. Now I'll just set my account ID to 1 for my account B. Check whether this has been correctly set. Yeah, I get my correct account ID here. Next, I'll try to list my test bucket from account number B. Access denied. Let's see the explainable IAM feature in LocalStack. So it says, could not retrieve your resource-based policies because of the permissions denied here. So it tells you which action and for which resource and for which principle this has been denied. On the other hand, if you were on AWS and you were a beginner, you would have been lost. So explainable IAM feature in LocalStack provides you a lot of informative information on what policies you shall require to access a particular kind of resource. Going back, let's just look at the policy that we'll set for my target resource test bucket here. So we set the version, we set a statement, a single statement here. Principal, as we talked about, is an element which will be using this permission, right? So who needs to use this permission is account number 1, because this will be listing the buckets for in account A. So I've set it to the same ARN as set here, right? Effect. Effect could be allow or deny depending on whatever you want the outcome to be. Next is the action. I want that this ARN should be able to perform my list bucket. And I could also see that from my console here, like list bucket operation, and also the resource that would be needing for this action, right? So we set the resource here. Let's just set the put bucket policy. Also, depending on which service you are trying to use, this is a resource based policy since we are attaching it to the S3 bucket here, and depending on what resource you are using, this operation may vary. So we just put the bucket policy in this test bucket and attach this policy here, right? And now we'll try to again use this. So yeah, that's a green, right? Now, what we actually did now is we have two accounts, account A and account B. We have created a bucket by the name test bucket in account A. We create a bucket, put an empty folder here. We try to list this test bucket and we get access denied error. We grant a permission to this test bucket and we get a successful result on account B using the list operation on this test bucket. And you can always find out more about IAM in our LocalStack documentations. So yeah, now let's dive into a real world example involving cross accounts to see how this works in practice. Now let's say we have three accounts, account A, B, and C here, and assume this to be a loan application submission system. Now, Team C here is a shared service account where a client is trying to submit the loan application through an API gateway endpoint, and the application is processed by a Lambda function, which then sends the messages to the SQS queues and uploads some file to S3 buckets in specific banks, which are in Team A and Team B. Now, Team C is basically the loan application processing systems. Team A and Team B are the banks. Team C has Lambda function and API gateway resources, and Team B has SQS and S3 bucket resources. Team A and Team C are in US East 1, whereas Team B is in EU West 1, right? Now, each banking institution we see here has its own AWS S3 bucket and a simple SQS queue, right? Now, this ensures that there is a proper data isolation and compliance with security regulations. And there is also a common system in account C, which hosts the API gateway and Lambda functions to manage the processing and notifications, right? So what we are trying to achieve here is resources in US East 1 are basically trying to connect to resources in EU West 1, right? Let's have some hands-on. Now I open my terminal again. We'll assume the first pane here to be in account A, second to be of account B, and this is account C. So this pane here should have SQS and S3, same for account B. And the third one should have Lambda and API gateway resources, right? So let's see what we have for each of these accounts and how we can create different resources, attach policies, and make this working. Yeah. So we set the account ID to 1 here, like 12 zeros is the account ID for me. Then I set the secret key, access key to be test. Now we ensure whether the account ID is being correctly set. And we fetch this account ID from here and output into a plain text format and store it in the account ID variable. right? Now we have queue name, which will be team hyphen queue hyphen the account ID, right? And then we have the bucket name, which would be team hyphen bucket hyphen again account ID. Now, what we do is create a queue with the queue name above created in line number 9, and we fetch the queue URL and output as a plain text here and store it in the queue URL and set the queue attributes. Now, since we saw that Lambda in account numbers in the third account will be accessing the SQS in account number A, right? So we need to attach a policy. And here we are using a resource-based policy. Let's see what we have in this policy. We open the SQS policy 1. We see that the principal here is the account number 3, which we'll just create in some time, will be accessing SQS, some kind of SQS operations on this resource, which is the queue, that would be created, right? So that is team hyphen queue hyphen the account ID queue. We grant this permission and set the queue attributes here. Then we create a bucket simply like by calling the S3 API create bucket operation and specifying the bucket name. Then again, we want a policy so that the Lambda in account C could again connect with account A. So we again attach a resource-based policy to S3 bucket residing in account A, right? So again, we see what is happening here. Yeah. So principal here with ARN of account 3 shall be able to perform S3 operations on my S3 bucket. And yeah, that's the infrastructure for account A. Let's deploy this for account A. Meanwhile, let's look what's happening in account B. So account B has a similar infrastructure, just that the resources in account B should be having account number 2s, like 12 twos, and it should have the region EU West 1 with the secret access key set to text. And we create a queue, set the policies for it, specifying which region we want to create this, and we again create a bucket, attach policy. So let's deploy this infra as well. Now, we have the third account in which we will be deploying our API gateway and the Lambda function. So we set the account ID here to 3, secret access key to test, create a Lambda execution role so that our Lambda is able to access our AWS resources, put a role policy to it. Then I'm using a zip, which is an inbuilt command line utility to create a deployment package for my Lambda function. Let's see what my Lambda function is doing here. So basically, it will take the attributes from my API gateway method that will just create a REST API to invoke my Lambda function. It will fetch the different attributes from it, and creates Boto clients for S3 and SQS. And what it does is puts an object in this bucket with team-bucket account, and with the key file name that a user will be sending, and then a content of this file, right? That will again be coming through the REST API. And we also send a message to the SQS queue, in the specified queue URL, and the message body should be file. This is uploaded to the bucket name that is of that particular account. Also, we have a response body here that will output with the status code. And it should consist of accounts, region, bucket name, bucket key, and the queue URL. Moving back to our account C infra, we'll then create the function here with the name common lambda. We'll attach the role, we'll create the runtime and the deployment package, and we'll shoot the command to deploy this. Next, we create is a REST API with the name common lambda API. And we then retrieve the API ID by listing all the APIs and filtering the ID with the name common lambda API. Further, we retrieve the root resource ID, right? I'll get all the resources, filter the ID with the root path and output as a plain text and store it in the resource ID. I'll now create a new resource, which is upload. I'll create a resource, attach it to the API ID and the parent to which I want the new path to connect to, and query and extract the ID and output it as a plain text to my upload resource ID. Now I'll attach a post method to this API, right? I'll basically just take my I'll call the put method handler, attach a REST API ID, upload the resource ID, I'll attach a upload resource ID and a post method. Next is I create integration between my Lambda function and the API gateway by specifying the REST API ID, the resource ID, the HTTP request, the HTTP method being used, and the type is AWS proxy. I'm using it here because I'm directly integrating it with the Lambda function. And then finally attaching the URI of my Lambda function here. And I create the deployment for this API and just tag this as a prod, a prod deployment, right? Now I'll also add a permission to the Lambda because my API gateway needs to access the Lambda because it will be invoking my Lambda function. So I'll set the Lambda invoke as the action that it needs to perform on the Lambda target. Principal is my Lambda function, common Lambda API. Source is the API gateway. And the source account is my 3, right? Now I deploy my infra for account C. I have pre-written a test here. Let's see. So what I do in my test is basically it's a parameterized test. I run it for both the accounts that I've just created, ran it against both the regions, and I fetch all the REST APIs in my account 3. So I have taken my Boto client here called the Boto client, and I list all the REST APIs. I see whether the common Lambda API that I just created is, so the account C package, account C infra is deployed. And we see that we basically list the APIs and see whether the common Lambda API is created. Next, we see the API stages. We had created one for prod, so we'll check whether that stage has been created. Next is the invoke API. We basically call this API through a post method, setting some parameters here. And now what we do is the response that would be output that we had created an output in the Lambda function for, and we'll check it against these parameters we have set while sending the post request to the API gateway. Right? And now we test the SQS messages, whether the received message is same as what we had intended to. And finally, check the S3 content again, whether it's same as what we had set to here in line number 43. So let's see whether this is functional or not. So we write PyTest and we'll wait for it to deploy and see. Yeah, so our results got passed. Let's get back to our slides. So what we basically achieved here is resources in US East 1 are were trying to access the resources in EU West 1. So yeah, that's done. Testing the application. So now let's see whether in our resource browser, these resources have actually been created or not, right? Let's wait for it to open. We'll go to the resource browser. We have US East 1 set as the region here, account ID to set all ones. So we know that we have SQS and the correct SQS queue has been made and approximate number of messages is 1. That's the desired output. And we also can see the S3 bucket. We have the bucket and we can download this and see. Yeah, so we have the correct message that we tried to send through our test. Hello from LocalStack from Team C. Similarly, we could even see for different regions, say EU West 1, we'll set it to 12 zeros and just refresh the page. We'll see the same things for the S3 bucket in account number 2. And let's see what we have for SQS here. Yeah, so it's also been correctly made. Similarly, we could also test this for our third account and we should expect Lambda and API gateway resources for this account. So let's see whether we have it or not. Yeah, so we have API gateway with the name Common Lambda API. And let's check whether our Lambda got deployed successfully. Yeah, so we have one with the name Common Lambda. We could see we could see what logs we have for this. And it should be invoked twice, since one for account 1 and the other for account ID 2, right? So yeah, it's been invoked twice. So yeah, we're good to go. Coming back to our slides, we saw how account C has Lambda and API gateway deployed. And then we could see account A, SQS, and S3 messages. And similarly for account B. Yeah, so we have almost come to the end of the session. To wrap up, let's quickly see what we just discovered today. So first is IAM policy enforcement is a very good feature in LocalStack that can be used to test your security policies and create more realistic environment that more closely resembles real AWS behavior. And LocalStack supports IAM, but it is disabled by default, and you could enable it by using enforce IAM variable. Next is the explainable IAM logs that we just saw in our terminal, and how the resource-based policies are helpful in multi-accounts and multi-regions to access different resources across across multiple accounts and different geographical locations. And then we have the multi-accounts and multi-regions in LocalStack, which can be achieved very easily, and it helps us in managing and deploying resources. And using LocalStack, we can stimulate more realistic AWS behavior without paying hefty bills, and replicate and emulate multi-accounts and multi-region functionality for testing and development purposes. So yeah, that's all for today's session. I'll open the floor for any questions now.